Hi everyone, my name is Quoding, and today I'm going to introduce to you my mobile test pyramid approach. It's based on my personal experience. Who of you is currently involved with mobile testing? Show hands. Whoa, wow. We've done that for the last 2 years? 3 years? 5 years maybe? More than 5 years? Wow, there's some real experts out there. Maybe you can share your experience after the talk. So this is based on my personal experience. This helps me, so I also hope it helps you. So who am I? I have over 10 years of experience in the software testing industry. I'm specialized in web, mobile, and API testing. So I go to different companies and implement test strategies, test automation strategies. And I've done my portion of agile development, so I've also done Scrum Master, Product Owner, and Lean Green Belt Consultancy. Based in the Netherlands, it's also where I'm from, born and raised. You find some contact details there. So when we talk about mobile testing, most people start with, let's get some real devices and install our app there and do some cool testing there, put it in the locker, and yeah, that works. But today everyone wants to do CI/CD, so you want to gain that fast feedback, so you have to look at other possibilities. So if you talk about mobile testing, you have other challenges compared to web UI testing. So in the desktop browser, you only have like this virtual stuff. On mobile, you have OS issues, network issues, authentication issues. So these are some examples. So to gain that fast feedback, there are different things you could utilize in your mobile testing strategy. So in my experience, real devices, of course, that's the real thing. But we also have mobile simulators, emulators. In my experience, I think that's the most underestimated part. Browsers, when I say browsers, I mean desktop browsers with mobile simulation. And in this talk, when I talk about mobile simulators and emulators, I talk about iOS simulators and Android emulators. So I'll go through each of them in this talk, see what the pros and cons are, how to apply them the best. But first, of course, I was inspired by the test pyramid. Everyone knows that. Who doesn't know the test pyramid? Cool. So everyone knows it. So Mike Cohn wrote this book, Succeeding with Agile, in 2009. He came up with this simple test pyramid approach. So actually, each layer in the pyramid represents, the broader the layer, the more tests you have, the more complex tests you have. And further up in the pyramid, so the UI tests, you don't have many UI tests because you covered all the other things on a lower layer, which is gaining that fast feedback. But when you talk about the mobile, so it's more UI based, but different factors you have to take into account there. You can also make a pyramid there, and that's how I came up with my mobile test pyramid approach. But before I show you the mobile test pyramid approach, there are a few guidelines. These are generic test guidelines I like to follow in practice. So test in isolation, that also means test in the right layer in the pyramid. Automation, zero tolerance of flakiness. If you run the same test 100 times in the same environment, same test data, same conditions, you want the same result every time. Not only for automation, but also for manual testing. So the fast feedback, already mentioned that. Regression is broken build, so don't break anything that was working. Risk-based testing, so when there's no risk, you don't need to test it, right? So generic guidelines I like to follow in practice. Non-functional requirements are just as important as functionals, especially on mobile. You have to deal with things like performance. So the mobile test pyramid. So it touches a few of these generic test guidelines. So on the bottom layer, we have the desktop browsers. So the desktop browsers use it with mobile simulation. This only applies to when you're dealing with a hybrid app or a web application. So you have more possibilities there. You have the mobile simulators and emulators. And then the real devices. I divided the real devices in 2 layers. One is more about the usability, so more functional testing. And the top layer is more the non-functional, so NFC touch performance. I'll go through each layer and see what you can do there. and summarize at the end. So the first layer, so mobile testing on desktop browsers. So pros and cons, it's super fast, it's scalable, you can run more than 10 instances on one machine, right? Cross-platform, so you can use browsers on Linux, Mac OS, Windows, doesn't matter. It's fast, so you can use it. The cons here, so I'm talking about mobile simulation. The rendering is different than on an actual device, so be careful with that, especially when you want to test visuals. I'll show you some examples in a minute. Of course, no native integration. I mean, no mobile native integration, like input text fields, drop-down lists, but also incoming calls, stuff like that. Of course, you're limited there. So it's just not a device, but it's very fast. You should utilize it if you're dealing with a hybrid app or web application. So what should you focus on with the desktop browser testing? So if you have the opportunity to test on this level in a pyramid, focus on the functional system testing, so your extensive functional testing, you can do it right there. Responsive design, you can resize the browser, play with the user agents, so simulate your mobile device. Cross-browser, so equivalent desktop browser. So let's say you want to test on a mobile Safari browser, use the desktop Safari, and for Chrome the same way. Last but not least, the overall visual layout. I mean, overall, because the rendering is different, and you know it's really different than the device. So you can see, hey, does it look okay-ish? That is what you can verify, but be careful with that. So what can you do? A small demo here. This is an automated test on Sauce Labs. Going to Airbnb.com, resizing the browser. So you really see a different experience per viewport. And if you combine it with a user agent, so again, it's automated test on Sauce Labs. Go to Airbnb.com, resize the browser, inject the user agent. You're an iPhone now, so now at the top you see this bar. You can install the Airbnb app, so you can verify this already on a browser, on a desktop browser, so to gain that fast feedback, so you don't have to wait until everything is compiled and ready on your mobile device. So it's great, right? It's fast. You can already verify a few things. Already mentioned it, visuals tricky. So shows you some examples. This is a great website of an Italian restaurant, right? Very responsive. You see the layout is different, the font size is different. Notice that on the right side there's the device, on the left side is the desktop browser with mobile simulation. You see that the top bar on the right has a yellow border on the device and does not show on a desktop browser. Another one, so again on the left, the desktop browser. So this site shows an alert, hey, this website is optimized for desktop and tablets. Well, if you want to verify this alert, well, it shows very differently on desktop than compared to a device. Either way, it's not very nicely shown, I think. Another example with some native elements. So on the right on device, you see an input text field and drop-down list. You don't see them on a desktop browser. However, they do function, so you can focus on the functional system testing here. But again, here you see a layout problem on the desktop browser. See the headers are not aligned properly, but on the device it does. So be careful when you try to verify visuals. More interactive example. So here we have a left menu that pops up. The whole area is draggable on a desktop browser, but on a mobile device, only the content area is draggable. So yeah, interaction, not a good place to do it with desktop browsers, but it's really fast. You can do the functional testing, so focus on that and responsive design and user agents. Next level, mobile simulators and emulators, closer to the actual mobile experience. Pros, well, it's easy to set up, it's free, well, it's virtual, so it's scalable. You have some native API integration, so incoming calls, GPS, Text messages, you can already verify that. iOS simulators are fast. The Intel-based emulators are also fast. So if you use something like Genymotion for Android, it's Intel-based. That also, brings us to the con of slow ARM-based emulators. If you look at the market, I think almost all Android devices are ARM-based. So don't focus on performance testing here. But functionally, it does work. So you can do some fast feedback here. Debugging possibilities are very good. It's already hooked up to your machine, so you have access to your logs and everything. Some more cons. Well, if you look at the Android emulators, you're limited to the vanilla versions. Yes, there are skins out there like Galaxy or Samsung Galaxy skins or HTC skins out there, but it's just a skin on top of your stock emulator, so it's not the real thing. Resource usage, CPU, memory, battery usage, it's not like a device. Some do say, hey, those emulators do emulate that hardware part. In my experience, it's not very close to the real experience. So connectivity with NFC, Bluetooth, network connections, there's no real connectivity there. ARM-based emulators already mentioned that. And color display was the one client. We had this app. We had to test the contrast, so color display. Well, of course, if you use emulators, simulators, you can really focus on that because it's not a device. So just to be aware of when you hit this layer of the pyramid, focus on the right things. So compared to the desktop browsers here, functional, go focus on the end user flow, so more the click path throughout the application. So it's more high level, not as extensive as the desktop browsers. Native API integration, so here you can do some native API integration like GPS injection, file attachments, incoming calls, vanilla visuals. Visuals are very good on simulation emulators. Well, for Android emulators, you're limited to vanilla versions only. So the other part you have to do on real devices. Touch interactions, like the example I showed you with the navigation menu popping up in the draggable area. This is the place in the pyramid where you can already gain that fast feedback on that part. So what could you do? Here's an example of an Android emulator. Here on the left, you see a GPS injection going from San Francisco to Kuala Lumpur and back to my hometown in the Netherlands. On the right, you saw an incoming call and a text message. This is automatable on Android. On iOS, I think it's a bit more difficult, but you have possibilities there already to gain that fast feedback in your continuous delivery. So the real thing, yes. So yeah, of course, the native APIs, but the real conditions. So you can focus on 3G, 4G, 2G, Bluetooth, NFC touch, stuff like that. So real connectivity. It can be faster than emulators. I mean, the ARM-based emulators, the real devices are just faster. Well, just the real thing. So you have the real resource usage, so CPU, memory. The cons, well, the costs, you have to buy the device, or if you're a cloud provider like Sauce Labs, pay per cradle. If tomorrow the iPhone 8 comes out, you have to wait until it's available, but maybe by then, you know, the iOS simulator is already available, so you can already gain that fast feedback. So, and if you want to do iOS automation, you need a special build. And in my experience, I've worked with a lot of mobile development teams. They already produce different kind of builds for their delivery. This is another special build, so you have to be aware of that, taking it into account. So focus areas, usability. So on browsers, we had the extensive system testing. On mobile emulators, simulators, more the click path throughout the application. Here's usability, so more the interaction. Is your app really usable? Performance, so CPU, memory usage, battery usage, network strengths. This is something you can focus on here. Well, native API integration, the example at the banking client where they had this banking app where you can pay by NFC. So you could do the integration testing with a real device that you install the app and pay by NFC at a payment station. Visuals, so I call them like the leftovers you couldn't do on the emulators on Android. The manufacturer's sauce, I mean, if you look at Samsung, they come with TouchWiz, which is like an operating system sauce on top of Android. So this can impact your test, so you can do it here. And if your customer base uses specific built-in browsers, this is also the way to go. So real devices, what can you do? This is an example from TechRadar, opening the same app on different devices. This is, of course, the performance test. You can also automate this, but here you see great differences between the devices. In this example, the iPhone 7 is the fastest. This is a pretty nice example. Here's another example. This is the Galaxy Note 7. This is out of battery test. I think if you look up the YouTube video online, you see that the Note 7 will blow up. Of course, only real devices you can do this. And if you do extensive testing, especially automated testing, you want to do it by yourself. So this was at a large Dutch bank I worked at. We set up our own little grid with Mac Minis, and it's pretty cool, a few weeks. And then you start to produce some cool new kind of devices. Here on the left, you have the iPhone with curved edges. On the top right, you have the Samsung Galaxy S6 with a curved battery cover. Pretty cool, but yeah, if you want to do it yourself, it's fun. If it's really small, you don't really run so many tests. But if you want to scale up, do continuous testing, really go with a cloud provider like Sauce Labs, because you don't want to deal with that device management in your software company. There are many best practices on mobile testing. I mean, if you Google best practice mobile testing, you can find lots of hits. I want to give you some getaways here based on my personal experience. Some generic ones: launch a clean device before each test. So that's either manual or automated. Make sure there are no previous cookies, local storage, or cache there, because that can influence your test. You want a clean test every time. You don't want that flakiness in your test suite. If you're dealing with a hybrid app, focus on your web view. So use your app with your web view on mobile simulators, emulators, because it's different than a mobile browser. The rendering is really different. So again, if you look at visuals, really just focus on your web view. Technical click areas. I call the fat finger click. Had this example in practice where they had this pop-up window with a cross on the top right corner where you can close that window, right? And they implemented this technical click area of 1 by 1 pixel. If you automate that, it works, because Selenium or Appium will execute a 1 by 1 pixel click. Actually, if you touch a mobile device with your finger, it finds the center point of that and tries to execute a 1 by 1 pixel click, technically. But from a usability point of view, try to test it with an actual fingers, because it's the center point is not always the same. So they had to increase the click area. For automation, some more from a usability point of view, use native keyboards. So does the right keyboard pop up? Maybe a numeric keyboard. Can you still scroll your page when it's shown? So do that instead of injecting text or send keys, because that's just closer to the actual user experience. Native gestures for usability, so touch and tap, focus on that. Also elements, scroll them into the view before clicking. the end user has more possibilities on browsers to scroll. On mobile, they're more limited, so you have to make sure they're actually clickable in the view. So mobile test pyramids. The lowest layer, that's the browsers for mobile testing, so mobile simulation. Extensive system testing and responsive design. So this is only for hybrid apps and mobile web applications. The mobile simulators, emulators, the functional end user flows, click paths throughout your application, focus on visuals. You cannot do everything here on Android. So that brings us to the other layer on real devices, the leftovers of visuals, and one of the key points, usability testing there. The real devices, the top layer, real life conditions, performance testing, 3G, 2G, 4G, NFC touch, GPS, stuff like that you can focus on there. All right, so this is my mobile test pyramid approach. I can take some questions.
So given the fact that it's way easier to do browser-based testing, most developers are going to be saying that's the way to go. How do you handle the inevitable argument that says, it works on this is the way it works for me, but you go to use it as a device, or better yet, you go to use a simulator, and there's not confidence in that simulator, and to say, yes, I'm using it in the simulator, and it renders like this, and they go, but it looks fine in my browser-based emulation. How do you fight that argument?
Well, find the examples in practice, like I showed you before. If you load your web application in the browser and compare it to a device, or you can find examples very easily because they really render differently, and they're quite hard to solve if you only focus on browsers. So yeah, find real examples. And try to focus on the right things at the right layer of the pyramid. So don't do performance testing in browsers, of course. Does that answer your question?
Yeah, but I guess the rest of my question was more along the lines of how do you enable them to be quickly able to validate? So you open something on a real device. How do you allow them to be able to validate that the changes that they've made actually fixes it if it's fine in your browser?
Yeah.
But it's not fine in the device.
Exactly.
And
So
you can't use the device because it's not deployed yet and blah, 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 blah.
yeah, so the mobile test pyramid approach is you have to go through each layer. It's not just only browsers or only real devices or only mobile simulators, emulators. You want to touch the right things at the right layer, so you can get you can gain the fast feedback on browsers, but not on stuff like performance, for example, because you have to see it on real devices and visuals. Yeah, also not on browsers. So when you are aware of that, you can focus on the right things at the right layer.
On one of your last slides, you said always test on clean devices.
Yeah.
Could you define that a little bit better? Because if you had an app out there for a while, a lot of your users already have the app installed, so you need to think about the upgrade path and that they may have data in there. So real users, their phones are anything but clean. So
yeah.
How do you account for that, or what do you mean by clean devices every time?
Good question. So by clean, I mean if you run a lot of tests. So let's say you have hundreds of tests running like continuously on devices. Eventually, it will impact other tests because you're reusing cache and stuff like that. So if you are testing functionality, you want to have those factors impact your test. But if you focus on performance or specifically those kind of risk areas, then design tests specifically with those scenarios. So then you fire up a device, install your app, do multiple things, and maybe do it 100 times, and then see it still works after that. But then your test goal is very focused, because otherwise, if you just test like a flow throughout your application, but it's part of a big suite, and and you have previous cache that influence your test, and you're like, hey, why does it fail this time, and next time it does not fail, and then you have to flaky test. So if you know that this is a risk factor, design specific tests for that.
Hello. So in Android, like we have lots of real device, like lots of maker, like Samsung, HTC.
Yeah.
So lots of. So I would like to know, like, what strategy would you suggest? Like, how many devices we should cover, or like OS basis, maker basis? And in your experience, how many times have you seen this bug is only occurring with this maker, but with not maker?
Yeah, there's no black and white answer to that. But what I can say from my experience is rely on data. So rely on what does your customers use. So if like 0.5% uses, I don't know, some HTC device, don't focus on that because the effort is just way too high for covering that risk. I also worked at the project where they're like, oh, we need to cover everything. You know, we have so many different devices. So we took up a grid, you know, with 20 devices. And then, you know, real devices, they're very flaky. I mean, startup and power issues, stuff like that. So you want to bring that down. And looking at the data, you can support that. You don't want to have a large set of device you want to test. So yeah, rely on the data.
Thank you.
Yeah, I would like to add a couple of points to that one, your question. Actually, there are some research reports available also, like App Annie and other things. They report the device coverage details, right? Like in this region, these are the popular devices, and if you have to get 80% of the coverage, you have to test on these 10-15 devices. Those kind of data also we get. And another thing is during the application development also, there are like various analytics softwares, like it may be Google Analytics or other kind of analytics tools available that will capture the real devices used by their customers. That data can be taken to get the best set of devices to be tested.
I also want to add one more thing to that. It also depends on the architecture. So let's say you have a hybrid app, you use a web view. If you look at Android, there are different versions of Chromium. Let's say you use something like an open source project like Crosswalk, then you can get rid of testing on all those legacy Android versions. So it also depends on your architecture. So it's a combination of I think customer data, your customer data, market data, so what devices are popular, and your architecture. All right.
I'm not sure fully if you'll have any input on this, but I work for Brightcove. We're an online software as a service video company. So
okay.
I'm actually doing QA playback testing automation across mobile devices and desktop. So I'm curious to see if you have any experience or information you can share about actually testing video specifically.
Videos, personally, I don't have that experience there, but what I do know that there are possibilities to automate that and to see, check the frame rates and quality of the video. Personally, I haven't done that, okay. But I think from a performance point of view, I think you want to see that on real devices, and maybe visually if it's rendered correctly on simulators and emulators.
It doesn't on simulators actually, which
okay.
I am actually using sauces or test objects now, real devices, because of that limitation.
Okay.
But yeah, thank you.
Thank you.
Any experience with the Unity applications, games? Unity games applications.
Games applications?
Yeah.
Not personally, but what I see in the market, game applications really focus on performance, battery usage as well. Much more than any other type of application, web applications. So it's more, I think they're more focused on non-functionals. It has to be really, really fast for a large customer base.
Okay.
Yeah. All right.
Yeah, actually to give answers for the video quality testing, not the traditional tools like SAS Labs or APM kind of tools. There are other tools available which are traditionally used for the device testing. Like for setup box testing, there are like tools like Storm Test. That is to test the quality of the video on the setup boxes, and they have the solutions to test the video quality on the mobile devices also. It's called Storm Test, and similarly there are other tools like Whitby. That's also like used for testing the video quality, including the frames per second, jerkiness, those kind of things on the devices, and including the mobile, Roku, and setup boxes. Maybe those tools you can explore for the video quality testing as well.
All right. Well, thank you for your time. I'll be around around this area, so find me if you have any questions. Thank you.